Good morning, this is Kavipriya, Assistant Professor, ECE Department, SNS College of Technology. I am going to discuss about the topic Schering and Wien Bridge, which is the types of the AC bridge. So Schering bridge is a bridge circuit. It is used for measuring the unknown capacitance, and you can even calculate the dissipation factor of the capacitance. So dissipation factor of the capacitor is the ratio of its resistance to the reactance. Schering bridge is basically a 4-arm alternating circuit bridge whose measurement depends on balancing the load on its arm. So we'll be having a 4 arms, and the components, passive components, will be connected in the four arms. So in one diagonal supply will be given, and to the other diagonal galvanometer will be connected. So the component C1 is an unknown capacitor, R1, R2 and R1, R3 and R4 are the resistance, and C2 is a standard capacitor. And C4 is a variable capacitor. So the balance condition can be obtained and by varying this R3 or R4. The balance condition is that Z1, Z4 should be equal to Z2 and Z3. Z1, Z4, Z2 and Z3 are the impedance, and we have an impedance equation for Z1, Z4, Z2 and Z3. Z1 is equal to R1 plus 1 by j omega C1, Z4 is R4 by 1 plus j omega C4 R4, Z2 is 1 by j omega C2 and Z3 is R3. On rearranging the equation, we will be getting the equation R1 R4 minus j R4 by omega C1 is equal to minus j R3 by j omega C2 plus C4 R4 R3 by C2, where 1 by j is equal to minus j. After getting this equation, we will be equating the real and imaginary terms. On equating the real terms, we can find the value of unknown resistance R1 is equal to R3C4 by C2. On equating the imaginary terms, we can find the value of unknown capacitance C1 is equal to R4C2 by R3. And we can find the value of the dissipation factor of a capacitor. The equation is omega C1 R1. So we know the value of R1 and C1. After substituting, we will be getting the value of dissipation factor D is equal to omega C4 R4. And next we are going to see about the advantages, drawbacks and applications of Schering bridge. Advantage is that the balance equations are free from frequency. The arrangement of this bridge is less costly when compared to other bridges. Drawback is that in both the equations we will be having a R3. So it is very difficult to obtain the balance. Applications of the Schering bridges are, it is used by generator, it is used by power engines, and it is also used in house industrial networks. And next one is a Wien bridge. Wien bridge is a AC electrical circuit. It is used for measuring the frequency, and also it is used for measurement of capacitance. The bridge can be used even at the high voltages. The Wien bridge has a combination of RNC in one arm, which is series in one arm and parallel in other arm. So we will be having this RNC connected to series in one arm, and parallel combination will be there in other arm. So we will be having a null detector or balance indicator which is connected across the two junctions. So indicator will show a null deflection once the bridges get balanced. So let Z1, Z2, Z3, Z4 are the impedance of AB, AD, BC and CD arms. So the value of Z1 is R1 by 1 plus j omega C1 R1, Z2 is R2 minus 1 by j omega C2, Z3 is R3 and Z4 is R4. And after we know the balance condition is Z1, Z4 should be equal to Z2, Z3. So we know the value of Z1, Z4, Z2 and Z3. We have to substitute it in the balance condition. And after substituting and simplifying, we will be equating the real terms. After equating the real terms, we will be getting this R4 by R3 will be equal to C1 by C2 plus R2 by R1. And by equating the imaginary terms, we will be getting 1 by j omega C2 R1 plus j omega C2 R2 will be equal to 0. From this we can find the value of omega, which is the angular frequency, is 1 by square root of R1 R2 C1 C2. We know that omega angular frequency and frequency are related by the equation omega is equal to 2 pi f. So instead of omega we can substitute 2 pi f, and from that we can find the value of f. F is equal to 1 by 2 pi square root of R1 R2 C1 C2. Here we are applying a condition that we are assuming that R1 R2 is equal to R and C1 C2 is equal to C. So if both the values are equal, what will be the equation? Then we will be getting the value of f is equal to 1 by 2 pi RC. So we can this is the equation for the equation of the frequency of the Wien bridge. And next is the advantages of Wien bridge. It has many advantages. First one is simple circuitry. It can be the components that is available in the Wien bridge are very simple components. So it is easily available components, namely resistors and capacitors. And it is cost effective. Since all the components that is used to design the Wien bridges are inexpensive, the cost of creating this bridge is also very cheaper. And next is quantitative measurements. The Wien bridge has a capability to measure the frequency and capacitance with the high accuracy. So high quantitative measurements are produced by this Wien bridge. And drawback is that limited frequency generation. It is very sensitive to large frequencies values, and circuit may get distracted at high frequency values. And so frequency generated by a bridge is limited between 100 Hz and 100 kHz. High output distortion. Due to susceptibility of this Wien bridge circuit to large frequency values, the resultant output signal is highly distorted. And it is a non-purely sinusoidal AC input voltage is present. So due to the presence of harmonic content, it is not a pure sinusoidal AC input voltage. So the balance condition of bridge is disrupted. Application. As far as applications are concerned, Wien bridge is used for purpose of measuring the frequency of an input voltage and capacitance of the circuit. It is used for analyzing distortion due to harmonic disturbance. It is also find application in the high frequency oscillator. It is used for estimating the frequency values in audio and radio oscillator. So that's all about the sharing and Wien bridge. In this we have seen the construction and operating principle of sharing bridge and Wien bridge. We have seen the advantages, drawbacks and applications for both the bridges. Thank you.